guys, we've talked about tangents before. We're now going to talk about tangents in terms of a circle. We've also talked about points of concurrency when we did all the in-center, orthocenter, all that stuff. We're now going to see it in terms of a circle with tangent lines. So let's go ahead and get started on this. So first things first, what is a tangent when it comes to a circle? Guys, a tangent is going to be a line that does not go inside the circle. It is going to intersect the circle at one single point. Guys, only one point, exactly one point. It is also going to have a special relationship with that circle. So first of all, that point where they intersect is called the point of concurrency. We've had that point before, guys, when we had the triangle, we had that point of concurrency within that where they all intersected. This is going to be where the tangent line intersects the circle. That A is the point of concurrency. That tangent line would be the line AB right here. This is also tangent. This AB right here would be tangent as well. It's going to intersect the circle at one point of concurrency, that point F. And when you have a circle that has a line tangent to it, it's going to have a special relationship with the radius or the diameter. It can be for the radius or the diameter of the circle. It is always going to form a right angle. Every single time. Tangents are always going to form right angles with the radii or the diameters. Guys, that's a huge concept. We're going to use it a lot today. You're going to see it over and over and over again. So tangents form right angles with the radii or diameters inside of a circle. That means that OF would be perpendicular to AB. Guys, perpendicular means it intersects, it forms right angles. You know the drill. That's old stuff. You're going to see a lot of old stuff come up today. Triangles add up to 180. Four-sided figures add up to 360. Isosceles triangles have base angles congruent. Old stuff keeps showing up. They expect you to carry it forward. Okay, guys. So the one thing you can't assume, because you can't assume a lot in geometry drawings, is that if it appears to be tangent, then it is going to be tangent. So they're not trying to trick you. If it looks like it hits a tangent, then it is going to be tangent. If this line hits this radius and it's tangent to it at this circle, then what kind of angle is formed right here? Right angle. Same thing would be true down here. The P right here would be hitting at your point of concurrency, and this would be a right angle. Now, I'm going to trace this just so you can see it. I'll do it in blue. This is a four-sided figure. And what does every four-sided figure add up to? 360. So this whole thing is going to add up to 360. And if we know three of the angles inside of a 360 degree four-sided figure, we can add up the 90, the 165, and the 90. Guys, y'all see where the angles are? The 90, the 165, and the 90. Everybody's clear on where those are at? Okay. And we can add that up. Grab your calculators, add that up for me. What's that give us? 345. Okay. So then 360 minus that 345 would put us at, should be 15, right? 15. So 15 would be our X right here. If you can't write it on the inside, you can put it on the outside. Some of these pictures are very small. Okay. Does anybody have a concern, question? It's a four-sided figure. You know three of them. Add them up. Subtract from 360. That gives you the fourth one. Okay, here we go. For the next one, if we're looking for this one in the middle, this X, we use the same idea again. This is a point of concurrency, so this is a right angle because this line would be tangent. This is a point of concurrency with this radius. That means this is going to be tangent, which means this is going to be a right angle. We know three of these angles out of the four inside this four-sided figure, so we'd add up 90 plus 60 plus 90. Y'all have the calculators, I don't. Add it up. What is it? 240? Yes? No? Yes? Okay. And then 360 minus that 240 would leave us how much for this angle where the X is? It's 120. And if you can fit it in there, great. If not, you can write it on the outside. X equals 120 something so I can see it. Anybody have any questions, concerns, anything about this situation? Okay, here we go, guys. Next thing. Oh wait, anybody still writing? I apologize. Okay, here we go. So we're going to use that right angle over and over and over again, guys. This is also a tangent, but it happens to be tangent to a diameter instead of a radius. It's still going to form a right angle. And what does every triangle on Earth add up to? 180. So we know two angles inside the triangle. They are 90 and 23. 90 and 23 adds up to 113. And then 180, see, that's why we're taking it later, minus 113 is going to leave us what? 67. And that would be our x. Okay, questions, concerns, anything? Okay, here we go. Right angle. We got 90 and 36. What does that give you? 126. And 180 minus 126 is 54. There we go. Be 54. Okay, now I'm going to add in some more old stuff. See, the directions even say if you add in old stuff with new, then you can do problems like these. Guys, you're going to be using some old ideas. The old idea that's the main thing in here is that an isosceles triangle has base angles that are congruent. An isosceles triangle has base angles that are congruent. So first thing we're going to do is use the idea that this angle right here, because it's tangent, is going to be 90. We okay so far? Questions, concerns, anything? Okay. So we need to get this angle up here at the top in order to be able to find x. So we're going to use this triangle, guys. These two sides right here, I'll change to red so you can see it really clearly. This right here and this right here are two sides to this triangle. They're both radii. What do you know about the radius in a circle? They're all what? The same. So these two have to be the same. If these are the same, that makes this an isosceles triangle. If this angle right here is 60, then this angle right here would also be 60. Okay, we can find the third angle because, well, we shouldn't even need to do the math, guys. If you know two of them are 60, then an equilateral triangle has 60, 60, and 60. You can always do this. You can also always do 60 plus 60 is 120. And 180 minus that 120 would be 60. You can do that math if you need to. If you don't recognize that it's an equilateral, 60, 60, 60. Alright, now some of y'all will see it, some of y'all will not, so I'm going to trace this. I'm going to trace it in blue so you can see it very clearly. We're worried about this big triangle. What angles matter in this big triangle? The 60 and the 90. This right angle right here and this 60 that is right here. Those are the two that matter. Because those are the two angles in the big triangle. That's the one we don't know. So you would add 60 plus 90. That would give you 150. And 180 minus 150 would leave you 30? It is a 30, 60, 90 triangle. Cool. Good observation. I didn't realize that. That's the first person that said that today. It is a 30, 60, 90.
So would it be like that for all?
No. No, only if they're 60 like here. That's the only time that happens. Yeah, it would be, but they don't. You'll see on the next one, they don't all do that. Okay, guys, here we go again. So first things first, if this is 74, this is the base angle in an isosceles triangle. So if this one's 74, this one is also going to be 74. You need to grab your calculator and do the math. 74 plus 74 gives us what? 148. And 180 minus 148 is going to give you, what is it? 32? Okay, sorry, I thought I heard something else. So 32. Now this triangle's small. Sorry, might have to write an arrow, but that's 32 in that corner. So now looking at the big triangle, I'm going to trace it in red. I've got this big triangle. So far, I only know one angle. I know this one is 32.
Well, there's also the right angle.
There's also the right angle, though. They've got the tangent right here. This one is right. This is a tangent, so it's going to be a right angle. So now I've got 90 plus that 32. 90 plus 32 would be 122. Is that right? Okay. And then 180 minus that 122 would leave us what? What was it? 58? Thank you. I can't write that in that space, guys. X is going to be 58. 58. Guys, you got to remember the right angle. The old stuff, the isosceles triangle, combined with the new stuff, the right angle, gets you to these answers. Old and new. Isosceles triangles combined with the right angles for the tangents. Anybody have any questions? Anybody still writing? No? Okay. Let's keep going. So the next thing we've got to deal with is Pythagorean theorem. Now guys, this is going to be the one thing that's going to cause some of y'all to have some issues. It involves solving equations. Please listen to me. It's old algebra. It's going to be foiling, first, outer, inner, last. Let's show you this pattern, show you how to do this. Don't panic. Okay, anytime you have a right angle, if you know this is a tangent, you can put the right angle symbol there, or if you're trying to prove that it's tangent, you're going to treat it like there's a right angle there. Okay, and you're going to use Pythagorean theorem. That's at a squared plus b squared equals c squared. In this case, the x would represent your a, so x squared. The 12 would represent your b, so it'd be 12 squared equals, on this side, guys, when we take and put these together, this is addition. You're combining these two lengths together. That would be written as x plus 8. And if you need to square it, it looks like this. X plus 8 squared. Okay. Which you're going to rewrite as x squared plus, guys, what's 12 times 12? 144 equals, and I'm going to write this as a binomial times a binomial. I'm just writing it twice, guys, so that we can FOIL it. If you remember the perfect square trinomial formula, and you know what I'm talking about, you can use that without having to FOIL. You can know the pattern. If you don't know that, I'm not trying to teach it right now. I'm just going to teach you FOIL to remind you, because you can do this easily, no matter what. So, here we go, guys. F-O-I-L. What does the F stand for? First. So, I'm multiplying the first times the first. Well, first of all, before we even do that, guys, just bring down the x squared plus the 144, just so it's down here. Okay, now let's do it again. What was x times x? Oh, x squared. You multiply the variables, you add their exponents. X times x is x squared. X times 8 for the outer two would be 8x. 8 times x would be 8x for the inner two. And then the last two, it's going to be 8 times 8, which is going to be 64. Okay, guys, let's make life easy. If you have an x squared on this side and an x squared on this side, what's going to happen to the x squareds? They're going to cancel each other out. It's going to make it 144 equals, we're going to combine like terms, guys. What's 8x plus 8x? 16x plus 64. Since I already have the 16x on the right, I need the number to go over to the left to get away from it. So I'm going to minus 64 minus 64. What is 144 minus 64? 80 equals 16x. Divide by 16, divide by 16. What's 80 divided by 16? 5 equals x. There we go. Some of them you'll be asked to find x. Some of them you'll be asked, is it a tangent based on Pythagorean theorem? Okay, yes ma'am.
Is it okay if I had remembered that it was the variable square?
That's the pattern. That's the perfect square trinomial pattern. Yes.
I
If you
just-
know that, you can
I
skip that.
I skipped
The foiling and
middle,
just
so
go
I
straight to
wanted
it.
know if that was okay.
Yep.
Okay.
Yep. Guys, if you remember the perfect square trinomial pattern, use it. But I'm not going to worry about the pattern right now. It's easier to learn FOIL than it is to go through and learn that pattern. So if you know it, great, use it. If not, just use FOIL. Okay, guys, here we go. Down here, guys, they're asking, is this segment tangent to the circle? If it's tangent, then what kind of angle would this be? Right. If it's right, then what works for this? Pythagorean theorem. So, guys, if the two sides are going to be tangent, then, if the two segments are going to be tangent to each other, then the two sides are going to be equal, and the answer is going to be yes. If it's not equal, then the answer would be no. Okay? So equal yes, not equal no. So, guys, these are easy because there's no variables in them. It's just plug in the numbers. If they're equal, yes. If they're not, no. This would be 7 squared plus 24 squared equals 25 squared. We should be able to work through this pretty quickly. What is 7 squared? 49. Plus what is 24 squared? 76. And then 20, I know that one. That one's 625. Check, make sure. Yes. Add 49 plus 5, 76. Is it 625? Okay. So they're equal. So the answer is yes. This is a tangent. Guys, that means this is a right angle. This line is tangent.
The next one isn't going to be tangent because a common Pythagorean triple is 4, 3, and 5.
3, 4, 5, yes.
Not a 5.
That is. So here we go. It's going to be 3 squared plus 4 squared equals 6 squared. And you're correct, it is not the correct Pythagorean triple. So this is going to be 9 plus 16 equals 36. Guys, what's 9 plus 16? 25. And 25 does not equal 36. Since they're not equal, then these lines would not be tangent, and the answer would be no. This would not be a right angle, guys. Okay. We got one last concept. Anything before we get to that last concept? And this one's easy. Usually these are the best problems on any test out of the whole year. People love these problems, and they're so easy. Okay, guys. The concept oh, wait. Anybody still writing? Yeah, take your time. Guys, let me know. This next concept, like I said, people love this. People do very well in this sections. I mean, this is some of the best questions out of the whole year. People like these and get them right. Here we go. So the whole idea is, guys, if you have tangents that are coming from the same point, then they are going to be equidistant to the circle. That means if I have a tangent CD and CB, these are both going to be congruent to each other. Since they're both tangents, CD is going to be congruent to BC. CD is going to be congruent to BC. That's the whole concept, guys. If they're tangent from the same point, they're going to be congruent. If they're tangent from the same point, they're congruent. So if I told you that this one right here was 10, then this one would have to be 10. This one is 1, this one has to be 1. If this one is 5, this one has to be, guys, it's not a hard concept. 4, 4. Whatever one side is, the other tangent has to be the same if they come from the same point. If they're both tangent from the same point, then they're going to be tangent. Guys, this is a set of segments that are circumscribed. Guys, we talked about this word before. It just means drawn around. Okay? Drawn, scribed, written. And then circum means it's going on the outside. Okay? Instead of inscribed, that means on the inside. This is on the outside. They're drawing these segments on the outside of this picture. and they're all tangent. If they're all tangent, they've all got to be congruent. They're going to ask you to find the perimeter using this concept. So here's what the problems look like. Guys, this is the way I do it. Find the perimeter of each one. So if this is 6, this is going to be 6. Add those together, put it out here, write 12 and circle it. I'm telling you this because people mess these up because of careless errors, not because they don't know how to do it. If this one is 3, this is going to be 3, which adds up to 6. Put it out here and circle it. If this one is 2, this one would have to be 2, which adds up to 4. Put it out here and circle it. If this one is 7, this one is 7. That adds up to 14. Put it out here and circle it. Add up all the ones that are circled, guys. You've already done the basic stuff. Now add up those 4 numbers. We don't have a unit, so we can't take and do anything, but add those up. What is it? 36? Do y'all agree? Okay, good. 36 would be the perimeter. It would be units. We don't have a unit, but it would just be regular units because it's perimeter. Okay, do the same thing on the next one. If this one's 10, this one's going to be 10. Add them together, that'd give you 20. If this one's 40, this one's going to be 40. Add them together, that would be 80. If this one's 22, this one's going to be 22, which adds up to 44. The reason I circle them is so I don't mix up the ones that are the single numbers versus they already had been added up. And then just add up the circled ones. It's 144. There you go. Okay, anybody have any questions, concerns, anything about these notes before we get y'all started? Guys, this is going to be assignment number 1. This is your fresh start. Take advantage.